The following presentation was recorded at the 2013 SouthEast LinuxFest in Charlotte, North Carolina. It is licensed under a Creative Commons license. For more information about the SouthEast LinuxFest, visit www.southeastlinuxfest.org. The SouthEast LinuxFest would like to thank the following diamond sponsors in 2013 for helping make these videos possible.
So, just a little bit about myself. I'm one of the developers on the Dogtag team. And so what we're going to talk about today is just a brief introduction. What is PKI? I suspect most everyone in here knows what it is, so we'll keep that pretty brief. We'll then talk about Dogtag, give you a little bit of background to the project and where it is and where it comes from. We'll do possibly a little demo, just installing Dogtag, show just kind of how easy it's become to do. One of the big things that we've added over the last release in Dogtag 10 is a RESTful interface that makes it really easy to write clients to interact with it. And so we'll talk a little bit about how you interact with Dogtag using REST and how you can write a client pretty easily. And then we'll talk about some future directions. So the first thing is, what is PKI? Yeah. So we have a need in general to be able to identify certain entities like governments, institutions, businesses, that kind of thing. When you go to bankofamerica.com, you have to be able to know that the site that you're going to is bankofamerica.com. And how do you do that? Well, you do that because it provides you a digital certificate, and you need to validate that certificate to make sure that the public key that's therein is actually a valid key. And so that's where certificate authorities come in. We need to identify people because there are applications where you can log into those applications and you can be prompted to be authenticated using the client certificate. When you generate a private and public key, you keep the private key. You publish the public key everywhere. And so you can do things like encrypt email, for example. Anyone that if you encrypt your email with your private key, anyone with a public key can read it. And if they send it back to you, encrypted in your public key, only you can read it. So encrypted email. Computers, applications, same kind of thing. I remember being at one particular customer where they actually have locomotives. So locomotives going along they have an engineer there, but the engineer doesn't do very much most of the time. Most of the time, if the locomotive has to slow down or speed up, it's all computer controlled. It's all controlled by a central server because that way they can maximize the fuel efficiency of the locomotive. So that needs software. And so whenever they need to download the software or new versions of the software, there is a there's a certificate exchange. Every locomotive, every device has a key, and so they make sure they encrypt things that way. So lots of different uses for public key cryptography, but essentially the idea is that you are generating a public-private key pair, and the private key you keep hidden, and the public key you publish everywhere, and that's how the mechanism works. We know that if you send something encrypted by your private key and it is decryptable by the public key, that it came from you because you've kept your private keys to yourself, and only you have that private key, and so therefore we can encrypt messages. And then finally, in order to validate the public keys that are being sent back and forth, you have to have a certificate authority, and the certificate authority is something that you trust. If you trust that certificate authority, and that certificate authority trusts the certificate authority that issued that certificate, then you know to trust that thing. So it's a web of trust, as it were. So just as a simple example, a client, secure web browsing. This is SSL, basically going to an encrypted HTTPS web page. You initiate contact, the server provides you a digital certificate. The client has to validate the validity of the certificate, so it's going to check to make sure the certificate's valid. It's going to check to make sure that the client certificate subject name it matches the certificate of the server. And then finally, it's going to check whether or not the certificate has been signed by a certificate authority that the client trusts. So in your browser, you have a whole bunch of certificate authorities that are pre-installed and trusted, and like VeriSign and so on. And so if the certificate is signed by VeriSign, or if the certificate is signed by a CA that was finally signed by VeriSign, then you're going to get, it's going to go through and everything's going to look okay, and you're going to get the little lock icon over there and everything's good. If it isn't okay, it's going to prompt up a big pop-up that says, this is an untrusted certificate, what do you want to do with it? And everyone just clicks, okay, 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 and kind of go through, right? So at that point, the client's going to generate a symmetric key. It's going to encrypt it with the server's public key, so it only gets to be read by the server and understood by the server. It's sent to the server decrypts it using its private key, and then finally they do the exchange, wrapping everything with a symmetric key. So it's key in setting up the encryption to begin with, in any case. So what is PKI? PKI is a public key infrastructure. And a public key infrastructure is something that has a community of people with private and public keys. It's going to have registration authorities that are going to accept certificate requests. They're going to accept requests with, you're going to send them your public key, and it's going to send that request to a CA to ask for a certificate for validation of that public key. You have the certificate authority that's actually going to issue the certificate to validate the public keys. You're going to have repositories where things are going to be public keys are going to be, and certificates are going to be published. You have revocation lists. So at some point, you need to revoke a suit. That's going to go into a revocation list, and of course, you're going to have online certificate status managers to do OCSP to confirm, online whether or not a certificate is valid. And then finally, you have key recovery authorities in order to recover lost encryption keys. So this is the case where, let's say you're on a corporate email or something like that. You have your public key, you have your private key, which is your signing key that determines who you are, and that stays with you forever. But then you have a key that you may use for encryption, which would be a different key. And that key could be used to encrypt your emails. And then you leave the company, and all of a sudden there's a whole list of emails that cannot be decrypted if they don't have that encryption key. So what very often happens is that when you go and you request for an encryption key, that key will be sent with your request to the certificate authority and then stored securely in a different location. So those are the types of things that you need in a PKI, and those are the types of things that Dogtag provides. So what is Dogtag? Dogtag is so it's a security framework that manages the entire life cycle of X509 certificates. So issuance, renewal, revocation, publishing, private key escrow, and token management. The other thing I didn't mention over there is token management. One of the things that you can do is to make your token, your suits and your keys that much more secure, is you make sure you put them on a token, because part of the problem is that you have, let's say you've generated a key inside your browser. Well, it's inside that browser on that machine, and now you go to a different machine. What you have to do is you have to export it from that browser into a P12 file, and then you have to move that P12 file over to the next, and you have to put it in there, and then you have to import it into your browser. Moving keys around is difficult. But if you generate the keys in a token, then one, it'll never leave the token. The tokens are designed that way. And two, you can port it back and forth all the way around. One of our biggest clients, and we'll talk about this a little further, has a token management system. So part of our Dogtag system is managing the tokens as well too, making sure you get certificates on the token, out of the token, that kind of thing. So we'll talk a little bit more about that. It is Red Hat certificate system is the I guess the commercial offering that's based on Dogtag. It is, common criteria certified, FIPS 140 level 2, et cetera, et cetera. So it has all the appropriate certifications. Our biggest customers, have these requirements and have to, it's essentially military grade. And part of this, there's a lot that's involved in here. So common criteria certification first means a lot of documentation. It means all the interfaces are documented and so on and so forth. But it also means very specific things that you can do with the keys. If you are in a common criteria certified environment, at the back of your server, any kind of, you will have hardware tokens that you store your server key, your keys on. And anytime you have any encryption operations, they take place in the hardware token. So that even if someone were to break into your server where you have, where you're running your CA, and was somewhere able to look through the memory on that server, they would not be able to find any keys. So it's all in the token, and all encryption and everything takes place within that token. Talk a little bit more about that, but that's the kind of security and the kind of safety that assurance that you get if you run Dogtag or Red Hat certificate system in a common criteria type environment. It's deployed by the largest PKI deployments in the world. There are millions and millions of keys and certs that have been deployed using Red Hat certificate system. And of course, the latest version of Dogtag is available on Fedora 18 and 19. So just a little bit of history about Dogtag. Dogtag, or a Red Hat certificate system, it's been around for a long time. It started out as the Netscape certificate server in 1997, 1.0. At that time, it was just the CA. Netscape certificate, about a couple of years later, they added a DRM. So DRM, which is or key recovery, that's the place where you store the keys. And then I guess it was sold to AOL, and then there was a fork that was done to Sun. So we had the Sun 1 certificate server that got forked off the Netscape iPlanet certificate management system 4.2. There was a 7.0 release that went in 2004, and then at that point, it was acquired by Red Hat, and Red Hat had its first release as Red Hat Certificate System 7.3. As we're going through here, and at various points, additional subsystems are being added and additional functionality, and I'll show you what the subsystems are in a second. 2008 is where Dogtag Certificate Server 1.0 started, and that was essentially, so up to now, we have something that was all closed source, everything, all closed source, and then at this point, this was the point that things were open sourced. So everything is open sourced. We have Dogtag Certificate Server 1.0, and if you're familiar with the way that Red Hat and Fedora work, there's a community project, and essentially all the latest development goes on there, and then it gets ported back, brought back eventually, and the next Red Hat release is based on that. So, for example, as we're going through here with the different releases, we decided we didn't just skip we didn't just have a bunch of releases that I'm skipping here. We decided at one point to have Red Hat Certificate Server 9.0 and Red Hat Certificate 8, Dogtag 9.0 and Dogtag 9.0. Red Hat Certificate Server 8.1 is based on Dogtag 9.0. Okay, so then we have Dogtag Certificate Server 10.0, which came out this year, and Red Hat Certificate Server 9 is going to be based on 10.0. Yeah.
So if I go with Dogtag Certificate Server, whatever the latest release is today,
Yep.
do I get everything I would if I went with instead Red Hat?
So the relationship is that the newest development takes place in the Dogtag, and then it gets pushed, and then it gets pulled back. So if you go with the latest, which is 10.0, then you're getting everything that is in Red Hat, well, in this case, Red Hat Certificate 8, right? And then eventually there will be a Red Hat Certificate Server 9, and that will be based on either 10.0 or 10.1, depending on what things are going. Right? Yeah. So the latest development takes place in Dogtag, and then it gets ported back. Yeah.
How dependent is it on a particular distribution, Red Hat? Is it like ingrained to the point of this, or is it fairly easy to use on distribution of X?
You mean like Ubuntu or?
Yeah.
Yeah. So right now for Dogtag 10, there's work to be done in order to be able to use it on something like Ubuntu, and we're working with those communities a little bit to get that. Part of that is in Dogtag 10 we added a RESTful interface, and the RESTful interface uses REST-Easy, which is a JBoss product. REST-Easy, most of REST-Easy is not in like Ubuntu, for example. So we're working with them right now to get all the various components, but there's a lot of components to REST-Easy, right, and a lot of dependencies that are underneath there. Not yet. Well, or try it at home and feel free to add, submit patches to these guys so that we can get it up there. So, all right. So main features of Dogtag, ability to create and manage certificates. It's highly easily deployable, maintainable. It's been around for a long, long time. It's highly scalable. And we have lots and lots of suits and CRLs and so on, millions of suits, really big CRLs that are moved around. Cloning for high availability. So each of the subsystems can be cloned, which essentially means that that you have two different servers that are sharing a database that is replicated between the two of them, and they look essentially like the same CA, if you have two CAs. But they're running within different serial number ranges, essentially. But they're essentially the same CAs, the same signing keys, so on and so forth. It's based on open protocols, open standards, so you can interoperate with any of the other subsystems, any other certificate systems, not just Red Hat. More features. Single CA can support multiple registration authorities. A lot of different ways of getting to the same CA. You can have root CAs, subordinate CAs, subordinate to, say, a VeriSign CA, for example, or to another. So you can create your web as much as you want to. You can cross-certify CAs. So if you have your one web over here with your root CA, you have another web over here with your root CA, if you cross-certify, you can expand the web of trust, as it were. Cloning. There are admin, agent, and end-entity interfaces. We'll see those in a little while, but we have, for common criteria, of course, we have logging and signed auditing. Signed auditing mean that the audit logs themselves are signed, and so if anything gets tampered with, you can run a tool and you can verify that things have been tampered with. And there are specific auditor certificates and so on and so forth. We have self-tests to make sure that everything comes up correctly. Different kinds of authentication and authorization. There are plugins whereby you can. It's a very big plugin architecture, so there are lots of different authentication plugins, and you can do authentication using certs. You can use authentication using pins or using LDAP, or you can add your own authentication modules. And of course, for certificate issuance, we have some things called profiles, and the profiles essentially determine what's in the certificate, what extensions are in the certificate, what authorization and authentication are required. And so we have a bunch of different profiles which are predefined for what most people use. But of course, it's all customizable. So you can create your own profile, which has its own inputs, its own outputs, and it'll automatically generate the various forms and so on to do these kinds of things. And as I mentioned before, it's a plugin framework, so there's a lot of things, just about everything can be customized in some way. And we've had to do this because our main customers have come up with very, very strange cases and have said, we would like to do X. And so we've put it in such a way that it's very customizable. It's a plugin, they write their own plugin, and they're able to do different things. Yeah?
Any notification when certificates are about to expire?
Yes, there is.
They'll send a trap or email saying.
Or an email, that's right. So, in fact, I think that's on the next slide. Right. So, publishing, perfect timing. Publishing notifications and jobs, right? So, you can configure publishers that publish the suits and the CRLs and so on to different LDAP servers. You have notifications which can be set up, so you can be notified when certificates are in your queue, for example, to be approved or something like that, or if certificates are going to expire, and those kinds of things. And you have various jobs that can set up to do those kinds of things. So CRLs, OCSP, generate CRLs. We have OCSP. The CA itself actually has an internal OCSP responder that you can point itself to, and we have our own OCSP subsystem, which you can offload that OCSP traffic to, if you want to do that. Yeah, OCSP online certificate. I think I said. Yes. Yeah, it's essentially a status protocol. So essentially, it's an online check of, your browser can go to an OCSP responder and can check whether or not a cert is valid. You can actually configure your browser to do that. If an OCSP responder is provided by a cert, go and check it and make sure that it's valid. Encryption key and escrow and recovery. And there are many different mechanisms for recovery, some of which are simpler than others. Some of our customers have wanted the kind of thing where you have 3 different agents that have to approve the recovery, and they all have to be in the room, and one of them has to type the thing, and then the screen goes blank, and the other one has to type the thing, and the screen goes blank, and the other one, and then you can recover the key, right? There's that kind of mechanism which is supported, and there are simpler methods that are supported for people who don't want to have 3 different agents in the room at the same time. All of that is there. There's support for hardware tokens, and for smart cards and crypto accelerators. So smart cards, which are the tokens. Hardware tokens, we're talking about the keys themselves for the system being on these hardware tokens, where it's really hard to get. You can't get the keys out. This would be the kind of thing if you had a common criteria certification. Yeah.
What about soft tokens or?
Soft tokens. Yep, soft tokens are supported as well too. Absolutely. Yep.
If you use the hardware, for the key storage, how do you PR?
There are ways. It depends on the hardware token.
Okay.
Yeah, exactly. Yeah, it depends on the hardware token. Right. I mean, each token has their own mechanisms for doing that kind of thing. Absolutely. SEP, so we have SEP so that we can talk to routers and other devices, and ultimately maybe talk to things like iPhones and things like that. That is something we'd like to do sometime in the future. And then, of course, like I mentioned before, there are multiple interfaces. There's a web UI, there's the RESTful interface which has been added, there are command line utilities, there's a console, which is a graphical client. Lots of different things, ways to get to it. Just as a quick mention, and I know that if you're more interested in IPA, Dimitri over there is going to be giving a talk next after mine about IPA, but essentially IPA is, Identity Policy Audit. It is, I guess it would be Red Hat's answer to Active Directory. In the back end, right now it does server suits as well too, and in the back end, here it is, it's using the Dogtag CA. And it is interacting with Dogtag through Python scripts. And part of that is also using Python to talk to the REST interface, which we've added. So, more details about our PA if you see Dimitri's talk. So, the various components of Dogtag, we have what we call the DRM, the Data Recovery Manager. That's where the keys are stored. We have the Certificate Manager, or the CA. So this is the Certificate Authority over here. We have registration authorities and OCSP responders. So if you imagine over here, as a user requests certs. The certs goes to a registration authority, and you can go directly to the CA, but in this case, we're going to a registration authority. The registration authority is a place where agents will look at the requests, will approve them, and will send that request off to the CA. And because it's an authorized agent, that certificate will automatically be approved and sent back to the registration authority. And back to the user. So this is the case where you would go into an office somewhere, for example, and you'd say, hey, I need a certificate. And you would go to that registration agent. The agent would say, okay, yep, you look great. You are who you say you are. And, I'm going to look at your driver's license, your military ID, whatever the case may be. And I'm going to issue a cert. And he's going to send that cert to the CA, and the CA is going to approve it, and it's going to come back, and it's going to go to the user. So that's one possible case. Another possible case, a lot of people don't have an RA. They just go directly. We have web pages that are directly on the CA. And you go and you request a cert. You can either have it automatically approved if you have whatever the appropriate profile is, or if it's not automatically approved, it'll go into an agent queue. The agent will look at the cert and say, okay, I know who you are. I'll issue that cert, and that cert is issued. Same time, if we revoke any certs, we're going to publish CRLs, and we're going to publish them and you can see them either by going to an offline OCSP responder, or there's an OCSP responder that's within the CA. And then finally, of course, if you try to get an encryption cert, what's going to happen is you're going to get that encryption cert, but when you get that encryption cert, your key, your private key for encryption, is going to go through the CA, and it's going to go to the DRM, and it's going to be stored in the DRM. We have to, of course, be very careful about how to do that because we're transmitting a private key over there. So what actually happens is that there's a transport certificate that is generated on the DRM, and on the user over here, the transport, the encryption certificate is wrapped in the transport key, in the transport cert, and it's sent all the way through there so that no components other than the DRM will ever be able to decrypt what's there. And if you're in a common criteria environment, it won't even be in memory over here because all of the decryption that takes place will happen inside the token. And then it's stored encrypted in the DRM. So there's a storage key, session keys, and storage keys that are generated to store within the DRM. So on the other side of there, you also have the token management system. There's the TPS, TKS, ESC. Okay, and here's just a little talk about the token management. In this case, you've got a smart card. The smart card goes to the enterprise security client, which is just a client that runs on your Linux PC. For Windows, there's a company called 90meter that had a client like this that also works. But essentially, you put your smart card in, and it starts to communicate with the TPS. You put your smart card in, you put in some credentials. At that point, the TPS sends the request to the certificate manager enrolls you, gets the request, and then issues the certs. The certs come back and get issued and get placed onto the smart card. The TPS over here is the token processing system sets up a secure channel and so on with the smart cards, and there's a standard for the kind of it's a global platform. There's a standard for the kinds of things that it needs to set up over there. And then finally, and then of course the other thing that it can do is if you have an encryption cert, is that the TPS will talk to the DRM and will store the keys on the DRM. So that's Dogtag. We can talk a little bit about installing Dogtag. And for here, I actually had I was hoping to do a demo, but things aren't. Give me a second here while I figure out how to get so I can see what I'm doing. Okay. Okay. So, I actually have let's try that again. Okay. Let me just okay, I don't know how that works. Yeah, okay, so it's working, it's showing something different over here, which is why I'm confused. So in case I couldn't do the demo, there's a YouTube video over there which describes, which shows how to do a Dogtag install. I'm not going to run that at this time. I think we're probably going to run out of time if we do that. It's very straightforward. And the essential steps are there that are there. And you get a Yum repo, install it. So I'm on Dogtag 18. You install a directory server instance, which is very easy. It was a one command kind of thing. And then you run the utility, which is pki spawn. And pki spawn, you're creating a CA. You can essentially keep all the defaults that are there, and in a couple of minutes it spits out a CA. And it spits out it'll create everything for you and configure everything for you. Now, of course, it's very customizable, and so you can actually provide it a config file, and the config file will customize the various things that you want. But for a standard kind of install, it puts you in a nice interactive menu that you can just click, and you can go through and get the defaults, specify the ports, and so on. This will give you a Tomcat instance because it runs on a Tomcat, and that will be your CA. And then if you wanted to, you could actually add an array, a K-array. K-array is the key recovery agent, which is the DRM, essentially, where we keep the keys. And you can add that to the same Tomcat instance. It doesn't have to be the same Tomcat instance, but it could be. And then essentially it'll go from there. The man pages for pki spawn give a lot of information about how to actually run it and do customizations and so on. So let me, I think we've sort of gone through this already, so. Well, let's see. Okay, so just as an idea as to the kinds of things that you do with Dogtag, and maybe I may be able to do a demo of this. So the idea here is that you have an end user. End user wants to create an encryption key and a signing key. They're going to be dual keys. They're going to be so they need to be. They're going to be separate from each other, and we want to escrow the encryption key. There's an enrollment form on the CA. It's going to take the enrollment form to the CA, and you're going to put in everything. And at that point, you're going to get a pop-up that says, we want to encrypt your encryption key. We want to send it over. Do you accept? And if you wanted to, you could look at the transport key for the DRM that's being used to wrap everything. So it gets wrapped at that point, and into the transport key and sent over. Again, it's wrapped by the DRM transport key. CA cannot decode it. No one can decode it except for the DRM. And so it gets sent to the DRM. It gets stored in the DRM. It gets unencrypted in the token, in the hardware token if you have one of those, and gets stored in the internal database, encrypted with another DRM transport key. If you're really interested, it gets, there's a session key that is generated, and the session key is it's encrypted with a session key, and then it's stored like that. And then there is the DRM storage key, which encrypts the session key. And so we put all those things inside there. So it's pretty complicated. But part of the reason for that is that if someone gets to your database and they're able to get to the storage key, then the only thing they can get to is the session key. And if they can get to the session, then they have to go through the session key to be able to get to the actual private key itself. Right? And then there's various notifications that go on the way back. So again, there's a very nice video there, which I don't know. That's a good question. So anyway, you will be able to get to these various sites over here. So let us go to the next. Oops. Oh, maybe it is trying to. Okay. Not quite sure what's going on there. Okay, so Dogtag architecture. Essentially, most of the Dogtag subsystems are Java subsystems. And the key point over here is at the bottom of the stack you have NSS. So NSS and the PKCS 11 modules are the things that do the encryption and the things that we rely on to talk to things like tokens and soft tokens and hardware tokens. That talks through JSS, which is the Java interface into NSS, and that of course talks to Tomcat through Tomcat JSS. And now you have your JRE and your JVM over here, which have all of the Java code in it. And so there are various modules, there's authentication, authorization, those kinds of things. And there are the legacy servlets. So remember, this has been around for a long, long time. There have been a lot of servlets that have been written to do various things. And so they're all the legacy servlets that are there. And there are the new servlets that have been added in Dogtag 10, which allow you to do REST. And they run in REST easy. And finally, on the top of things, you have your users that are communicating through the SSL ports or the non-SSL ports to either the end entity or agent or admin interface. So yep.
Are you using non-SSL ports for?
You can use non-SSL ports for OCSP responses, for example. And there are certain kinds of enrollments that you can do through non-SSL ports. An end entity user, so a user who wants a certificate might go to a non-SSL port and do some requests on how to get there, for that certificate, for example. So requests like that, or for OCSP responses where you don't need SSL. So anything that's security sensitive would have to be on the other side. So why a new RESTful interface? As I'd mentioned, this has been around for a long time. A lot of this started off in 1997, so it predated a lot of the new Java development and a lot of the new thinking in terms of how to interface with a subsystem. So essentially, the old interface had a bunch of servlet calls with name value pairs that being passed over. And while that's good in itself, it makes it difficult to interoperate with. It makes it difficult to write clients for. Partly because this happened before a lot of the newer Java technologies, you can see code in there where we're doing things like handcrafting HTML responses, where the error codes are not necessarily consistent, that kind of thing. Now, people that have written clients against this, have written clients successfully against it over the years, and it all works. But for new people coming in, it's kind of hard. Instead, we added a new RESTful interface. So the old interfaces are still there, and they have to be there to keep our current clients happy. But going forward, we'll encourage people to use the newer ones because they're newer and spiffier, and they're easier to debug and figure out what's going on. the application is presented as a collection of resources. So what kind of resources would you expect to see from a CA? Well, you'd expect to see certificate requests. You'd expect to see certificates. What would you expect to see from a DRM? You'd expect to see keys or key requests or things like that. So they're a collection of resources just as sort of in a RESTful framework. It means that you have much more intuitive URLs. So as a collection of resources, and there are, within the REST philosophy of things, there are certain things that you can do. You can do a GET requests, PUT requests, POST requests, and each of those operations has a specific meaning as to what you're doing to the state of these individual resources. So it means that the set of operations that are being done are much more clearly defined and much more restricted. And so you end up with much more intuitive URLs. So if I want, for example, to create a new certificate request, the old way of doing it would be to do a post to profile submit servlet SSL client, okay, which is about as intuitive as it could be. The new way of doing it is to do a post to cert requests. And at that point, you're going to send in the appropriate object, and the object will go to there and create a new certificate request. So standard operations, because now we use the REST-easy framework, we now have standardized responses. So in fact, now there's no longer any code that does the handcrafting of HTML, of HTML or JSON or XML. Basically, we tell the framework what to send back, and then the framework goes ahead and using JAXB annotations and using various types of annotations determines how to turn the objects that need to be sent back into XML, into XML or into JSON and send it back. And we have standard return codes as well too now. So that's pretty nice. Having the framework there to handle the serialization on the server side is really nice. And at the same time on the client side, because we use REST-easy, we use a REST-easy client proxy framework where you can use exactly the same kind of thing on the other side to do all the deserialization on that side. So that in your client, you never have to worry about deserializing and changing XML or JSON into various types of objects. Yeah. Yes, we do, yes. And we'll talk about that next, but yes. So REST resources on the CA. So on the CA, we have certs, cert requests, users, groups, profiles. Okay, those are the things that you find there. Certs, certificates, cert requests, requests for certificates. You have various users and groups that you can do. So this is the administration of the CA, and profiles, again, is the certificate profiles. You can do things like configure your own type of profile and so on. Not all of these are fully, profiles is the next thing, as we talk about future directions, is the next thing to be completed, but most of the rest of these are completed. So if you want to list all your certificates, for example, you do a get on /certs. If you want to get a specific cert, you do a get on /cert/ID, where ID is this, there are various IDs that are available. You can do a post to /cert/certs. In this case, it's a post because there are multiple different ways that you can search. If you want to create a new cert request, you do a post on /cert requests. And if you want to create a new user, for example, you do a post on /admin/users. The admin, some of these say admin, some of these say agent beforehand, because we have to, a lot of these operations require authentication. And you either require agent authentication or admin authentication. And there are different ways of doing that. So the way we made sure that it got the right authentication is partly through annotations and partly through standardizing the URL. Yeah.
Can you define the difference between agent and admin?
Yes. And this is a common criteria sort of thing, but an agent is someone that handles certificate operations. So someone that can approve certs, for example, or cert requests and issue certificates, and can approve profiles and things like that. And an admin is someone who can manage users for example, can add users, add more agents to the system, but in general is not someone that does any certificate operations. Okay, but basically. And there's for common criteria, it's a little weird because you have to have more than one agent approve a profile. So, for example, so the way we did that is an admin can modify a profile and an agent has to approve it. So you have to have two different people, conceivably. Now that person could be the one and the same person, but they have to. There's at least two different users there. Okay, so the REST Easy Client Proxy Framework, which as I mentioned before, it's really nice. It's a way of using JAX-RS annotations on the client side. What that means is that the client and the server share an annotated interfaces. So there are interface classes that are shared between both of these, and this defines the exact interface that you're going to use when you're writing a client. And what the server is going to show. So on the client side, the framework will take the request that you have and do all the serialization and deserialization and send over the appropriate objects and make the appropriate REST call. And on the server side, it's going to do the deserialization of everything there and turn it into objects and act on it. Send back the appropriate objects, serialized in the right way, and on the client side, it's going to be unpacked. And all of this is done by the framework, which is really nice. So you never have to worry about that. And I'll show you, hopefully, if I can figure out how to get it to display a bit of code that does that. So the client, again, instantiates these REST resources and creates proxy objects, and these proxy objects handle all the things you have to do, and then all you're doing at that point is you are making method calls on these objects rather than trying to do all these other things. So the client framework will then convert it to HTTP requests and marshal it to either JSON or an XML, and then ultimately it goes on to the other side. We have a new CLI, new client interface over here, command line interface called just PKI, and that uses that client framework extensively. It's really nice if you, you can do sort of PKI and just do auto completion kind of sort of things, and it tells you the kinds of things that you'll be able to do. So writing client code for the REST interface, very easy in Java, as I've mentioned. There's another YouTube movie which I put up there, which I will try and do now. But before I do that, there is some Python support that's available, which needs to be enhanced. Ultimately, we want to be able to make the Python support as easy as the Java support, so that on the Python side, you can just instantiate an object and call method calls, and have us worry about doing the serialization back and forth. It's not quite there in Python yet, but it is absolutely there in Java. The REST interface is, of course, documented at these various resources here. So let me try, and see if I can figure out how to get this to be displayed. My browser in the other window? Okay. Okay. This one. I don't know. Okay, hang on just a sec. Let me. Either that, or if I can get to Eclipse. Sure. Okay, well, there's Eclipse. All right, so the movie would have been me clicking through Eclipse, so this will be the same sort of thing as me clicking through Eclipse. It's kind of weird to see a movie, do a presentation, and have a movie of yourself talking about a presentation. So, but here is, so here, for example, this is on the client side. This is a class called CA client. And the CA client is something that would be instantiated on the client side. What you'll notice is that you can instantiate this client by passing in something called a client config object. A client config object is just a bean object that basically has the kinds of things that you would need to do to, it tells you how to do your connection. So it has things like the server URI, has things like where your client database is in case you have to do client authentication. So you need a certificate in a client database that tells you how to get there and what the nickname of that cert is and so on. But that's the client config. You pass that in. We have a helper class called PKI client, which does the connections for you. And then you'll notice the next thing we do is we create proxies for these three types of objects over here, these three types of resources, the cert resource, a cert request resource, and a profile resource. And if you look at one of these, okay, if you look at one of these, this is exactly the interface that is shared between the client and the server, right? So you can see that we have, it's a bunch of method calls that are defined. These are the method calls that are essentially that you're going to call. It tells you what you need to put in, what comes out. There's a path over here, so this tells you that this, if you were to call, for example, enroll cert, it would ultimately end up doing a post to cert requests, serializing things in the appropriate way. And how does it know how to serialize those things? It knows how to serialize, for example, a cert enrollment request. Because a cert enrollment request itself has annotations. And the annotations themselves, these are JAXB annotations that tell it how to turn this object into JSON, okay, or turn JSON back into JSON or into XML, or to take the XML and turn it back. Okay, so how do you use this thing? Well, basically, we have some test code over here, which can show you kind of how to use it. So get all the way up here. Okay, so in this code over here, okay, you can see basically we're initializing sort of tokens on getting our client cert, but we're going to create a CA client, and then when after you've created the CA client and you've passed in your config, we're going to do things like list requests and so on and so forth. And when you call client list requests, for example, it's going to take that. It's not just doing a method call, right? It's taking it and it's turning it into an HTTP request, sending it off to the server, with the appropriate serialization, sending it off to the server, sending it back, getting the response, deserializing the response appropriately, and putting it into a Java object. But that's all you need to do. You don't have to worry about all those details. You just need to worry about what to do once you have the request there. And so there's this code, and then of course there's the code for the PKI command line utility that shows you how to basically do this kind of stuff. It's pretty easy. I'm sorry. Yes, it is. It is absolutely. So everything I've mentioned over here is in the distro. So okay. So now let's go back to. Good. Okay. Okay. Similarly, just to mention, these are the DRM resources, REST resources that are on the DRM. So we have things like keys, key requests, users groups, and some other system, but basically keys and keys requests are the most important things. And of course, so for example, if you want to list the key requests, you can do get agent key requests. Notice that all of these have an agent appended to the beginning of the URL because they're all things that are sensitive and require authentication of various sorts. So you can do things like archive keys and approve keys and so on and so forth. Now, one of the things that you'll notice there's an ID thing inside here. And this is one of the enhancements we further did to the DRM. So the DRM is traditionally used to store X509 private keys only. and we use the public key as an identifier. But with the REST interface, we allow the client to provide an identifier, a client ID identifier, which means that theoretically you could store just about anything in the DRM as long as it's packaged properly. And the reason we did this is we wanted to, we had a case where we were thinking about escrowing disk encryption keys. So these are symmetric keys used to encrypt disks. And then ultimately what would happen is that when you start up a disk, for example, in a cloud or something like that, it needs its keys to be unencrypted. So you would go to the server and it would be able to retrieve these encryption keys. But we wanted to do it as sort of a proof of concept. We didn't want to implement something like KMIP, because we weren't quite sure if that we were going to completely do it. But you can take anything and you can put it into sort of the same CRMF structure that you use for private keys, and then you can send it off to the DRM. And as long as it's in the appropriate package and gets unencoded and so on, it can be stored and can be retrieved accordingly. Okay. And so over here we have some sample code that does exactly that. It stores things like symmetric keys and stores things like passphrases, for example. Anything you can conceivably want to store over there. We haven't tested it for things that are larger than the size of a key, of an asymmetric key, so that may be tricky. We may have to add things to fix that. But in general, for the things that we try to store, things seem to work out okay. And in fact, this new capability is being investigated currently as a backend to the CloudKeep group. And the CloudKeep group they're at Rackspace, they're trying to design they have an API, and they're trying to design something that will store keys and certs and all secrets, essentially, in one place on their network. And they're thinking about using the DRM as a backend for that. So using this functionality, kind of cool. Future directions. Dogtag 10.1 scheduled for Fedora 20, which is January next year. Pretty soon, actually, from the looks of things. We're going to extend the REST interface to manage certificate profiles, and then FreeIPA is going to use that to start managing their profiles and so on, add your own profiles. We're going to enhance the Python framework so that it makes it at least as easy as the Java framework. And we're actually taking one of the components, the TPS, which is actually an Apache component right now. We're going to rewrite it as a Java component residing in a Tomcat instance. And if we do that, then we may be able to take that and put it in IPA and have IPA as a complete solution, one Tomcat solution for doing all of your token management in one shot. So.
You mentioned Tomcat a lot. Is there anything specific to Dogtag that requires you to run on Tomcat, or what are you we have not put it in another web server yet. So another application server yet. So there has been talk about putting it in, say, JBoss or something like that, and there would have to be some repackaging that's done. Because right now we kind of take it and we explode. It's not in an ear or anything like that. Yeah, it's not or a war or anything like that. It's just. But there's been talk about doing that, but we haven't done it yet. So there's work to be done there. Yeah.
One of the use cases that I see this might be interesting is we currently have to we do business-to-business partnerships, and so business A wants to talk to business B. We have our own CA. They send us their certificate. We send them our certificate.
Okay.
And they have our signing cert. That could all be automated with that, right?
Yes, absolutely.
And we just do REST and just having an API that would say, okay, it's the first time I've seen you. Now, does it partition the data store inside of whatever the key store thing is you can do by group, so like group A can only see group A's keys and group B can only see group B's keys?
In general, if you have agents that are on the DRM, they can pretty much see all the keys that are there. So we don't, right. So we don't have any, we don't have any partitioning that way.
You do it prior to that, just make sure.
Exactly. You might be able to write some sort of thing that does that. But yes, within the DRM itself, an agent will be able to store it. That's right. Okay. Resources, IRCs. We're always on IRC, so if you want to get hold of us, that's the easiest and simplest way to do so. There are various mailing lists, Project Track, and so on and so forth. Questions? Any more questions? Yes.
What's your name on Freeload?
My name Freeload is A. Lee, usually. So I say usually because there's someone else who has the registered name A. Lee, so we kind of fight over it, whoever gets on there first. But A. Lee or A. Lee _ whatever. So. I'm sorry?
Your handle?
My handle? A. Lee. A. Lee. A-L-E-E, yeah. So, all right. Any other questions? I think I'm exactly on time. So.
Most enterprises today realize that usernames and passwords alone aren't enough to keep their network safe from unauthorized intrusions. That's why two-factor authentication has gotten so popular lately. It adds that extra layer of protection enterprise networks need to stay safe. But what you may not know is that some two-factor authentication solutions, they're better than others, like two-factor strong authentication with Wicked. Wicked goes beyond other authentication systems by being less expensive, easier to implement, and easier to use, giving you software-based token clients built to run on all major devices and OSs, including iOS and Android. These tokens utilize a public-private key combination that's generated on device, so there aren't any shared secrets flying around for attackers to hijack, or which require any special handling. Instead, all keys are kept secure and private between the requesting token and your server, which you control in-house, making it the most secure way possible to perform authentication encryption. And with an extensive, flexible API and support for protocols like LDAP and Radius, Wicked works with any enterprise network architecture to protect the IT systems vital to your enterprise. Download your Wicked free trial today, regardless of whether you're considering two-factor authentication for the first time or just ready to ditch your existing expensive key fob system. We can help with easy-to-implement, easy-to-use, strong authentication. From Wicked.
Cloud stacks are everywhere.
This is the way to better utilize all your resources, and it makes managing all your resources pretty easy.
All of the innovation is happening in open source.
The collaborative nature and of the community and the speed at which these deficiencies, these bugs are getting discovered and then fixed is a thing that really shows the power of the open source community.
It is global, and it's definitely because of the users.
Community people are extremely friendly and always ready to help.
If you go onto IRC any day, you'll see these guys helping each other out, and they're all doing it like in a selfless manner.
The product is transparent for everyone. Everyone can look at the code base. Everyone can see how Cloud Stack is being built. Nothing is proprietary. Everything is open.
In many ways, it's absolutely vital to the ongoing health of Cloud Stack.
The most exciting event in recent memory for me was our first developer boot camp. And our call gave people, I think, maybe 2 weeks notice to come attend. I was expecting 25 or 30 people. So we ended up with 87 people and had to go get more chairs into the room twice.
Everything within cloud computing is commodity and is open source. And so I don't think that you will you'll see anywhere where open source is not pervasive in cloud computing. And so I think it's an assumption. I think when you talk about cloud computing, you're really talking about open source cloud computing.
CloudStack is a robust solution for large deployments.
You have dozens of data centers and thousands of servers in each data center. These hardware is going to fail, and CloudStack is designed to handle, number one, that mass scale. Number two, it's designed to handle the failure that inevitably happens in large deployments.
We started working on CloudStack over 4 years ago, and it was the original set of people working on it had a background of delivering software to telcos and service providers.
Lots of QA, lots of users actually using it.
High availability is the key feature. Multiple hypervisor support, different network models. You can pick up whatever suits you better.
CloudStack management server can be deployed in different physical machines.
It definitely has a huge footprint. It's being deployed everywhere.
There's a major movie studio that they were using CloudStack. They were using it to transcode video, and I thought that was terribly fascinating. What I found more fascinating is what they did during lunch, where they would spin up 50 or 60 game servers. Then as soon as lunch was over, they would destroy all the instances and go back to doing real work.
CloudStack is vast. It touches so many different aspects, and there's no one person that's kind of like a master of all those realms.
I think CloudStack as a project is going to be one of the leaders, simply because it's some of the most featureful and robust platforms out there.
I don't see any limits to the CloudStack.
When we created Asterisk over a decade ago, we could not have imagined that Asterisk would not only become the most widely adopted open source communication software on the planet, but that it would impact the entire industry in the way that it has. Today, Asterisk has found its way into more than 170 countries and virtually every Fortune 1000 company.
The success of Asterisk has enabled a transition of power from the hands of the traditional proprietary phone vendors into the hands of the users and administrators of phone systems. Using this power, our customers have created all sorts of business-changing applications, from small office phone systems to mission-critical call centers to international carrier networks. In fact, there's even an entire country whose communications infrastructure runs on Asterisk.
Digium has always been about creating technology that expands communications capabilities in ways that we could never have imagined. And that's part of what's game-changing about Digium. Today, we're doing it again, this time by introducing a new family of HD IP phones that extends control of the user all the way to the desktop.
The launch of these new products represents the next phase in Digium's history of innovation. These are the first and only IP phones designed to fully leverage the power of Asterisk. When we first discussed our expectations for building a family of phones for use with Asterisk, our requirements were pretty simple. We asked the team to build the phones such that they were easy to install, integrate, provision, and use. I think you'll soon agree our engineers have delivered on that goal. User feedback is validating that when it comes to operation with Asterisk-based systems, including our own SwitchVox-based product, these are the easiest to use, best integrated, most interoperable products on the market today. The Digium family of phones will initially include 3 IP desk phones, uniquely designed to complement any Asterisk or SwitchVox-based solution. These phones are different for a number of reasons. First, they're exclusively designed for use with Asterisk. Secondly, we've made it really easy to auto-discover and provision the phones. Next, we've made it easy for the phones to access information inside of Asterisk, allowing tight coupling between an application and the phone. Additionally, we've created an applications engine that allows users and developers to create and run their own apps on the phone. And finally, we've done all of this at a very compelling price point. At Digium, we're always thinking of ways to give our customers the best value in business phone systems, and also give them the power to create their own solutions for any communications challenge.
We'll continue to push the boundaries, not only to make Asterisk cooler, faster, and more technologically feature-rich, but to make Asterisk and VoIP communications even easier.
And together, we'll change the way the world communicates.
Again.
Your customers rely on your website or application. If it's slow or non-responsive, it infuriates your users and costs you money. Keeping your business-critical systems humming along requires insight into what they're doing. Your system metrics tell stories that can reveal performance bottlenecks, resource limitations, and other problems. But how do you keep an eye on all of your system's performance metrics in real time and record this data for later analysis? Enter Longview, the new way to see what's really going on under the hood. The Longview dashboard lets you visualize the status of all your systems, providing you with a bird's-eye view of your entire fleet. You can sort by CPU, memory, swap, processes load, and network usage. Click a specific system to access its individual dashboard, then click and drag to zoom in on choke points and get more detail. Comprehensive network data, including inbound and outbound traffic, is available on the Network tab, and disk writes and free space on the Disks tab, while the Process Explorer displays usage statistics for individual processes. The System Info tab shows listening services, active connections, and available updates. Adding Longview to a system is easy. Just click the button, copy the one-line installation command, then run the command on your Linux system to complete the process. The agent will begin collecting data and sending it to Longview. Then the graphs start rolling. Use Longview to gain visibility into your servers, so when your website or app heats up, it stays up.